everybody, Bill Sky, the C++ guy here. Once again, this time we're going to look at constants and scope. So let's do the constants first, and then we'll do the scope. We can actually demonstrate how the constants and the scope can kind of interact. And there's also going to be a little bit of variable work here. No presentation, all demonstration. So let's get going. So I've got my Linux up here with Eclipse. Again, you can do this in Visual Studio Code, you can do this in Windows, you can do this in Mac, no problem. We're not going to do anything specific to any operating systems. That's one of the nice things about C++. It's pretty consistent across all operating systems. So the first things I want to talk about are constants. A constant is a variable, and it's not even a variable. A constant is a value that you give a label. And then the compiler distributes that value everywhere in your program where you use the label. So a constant simply begins with const, the data type name, and I'm just going to say my age. And then you give it a value. Oh, wait a minute, I'm not that. I'm 39. There you go. Okay. So what this means is that you've assigned a value to my age. It's an integer, and it's also a constant. What that means is that I can't change it. So if I say my age equals 0, and if I try to build that, I will get a compiler error. It says error assignment of a read-only variable my image. And it's not really even a variable. It is a label that, or it's a value that the preprocessor and or the compiler goes and replaces all of those constant names with that value. So for instance, the compiler or the preprocessor, everywhere it sees my age, it'll put the number 39. And if you try to do that, if you try to assign a value 8 or a value 0 to 39, that's like trying to say that the number 1 is the number 10. You can't assign a literal. And the error is not quite the same, but it kind of is. It says you can't assign something to a literal. So that's really what the compiler does, and that's why you cannot do something like this. Now, the other thing I wanted to show you is that I also named my constant all uppercase. Now, you can put underscores there. Okay, that can help. But the reason for that has nothing to do with syntax. You don't have to put all uppercases for a constant's name. But it's an industry standard. It makes it very easy to, when you're looking at your code, to say, hey, that's a constant because it's all uppercase. And the include files do that as well. There's a constant called climits, or int max, I believe. So if I pound include climits, then what I can do is I can count int underscore max. And int underscore max is a constant that's defined inside of climits. And so even the language standard uses all uppercases for these names. So if you're creating a constant, something like this, you're basically going to be laughed out of a code review. And for those of you who don't know what a code review is, it's when you finish writing your code and you take it to the rest of the department, or you take it to people on your development team, they review your code, and they're going to see this, and any legacy or experienced C or C++ programmer is going to tell you that's ridiculous. You don't create a constant lowercase like that. So I would replace it with that. And every textbook does it that way as well. So, and you know, when you're dealing with making money, you want to conform so you can make as much money as you can. So I would, and you will end up appreciating that later on. So that's what a constant is. So you can use that constant anywhere. I can put it in couts. I can use it in equations. Like I can create another integer. and I can assign my int. I can do it as many times as I want with as many constants as I have. So constants are simply a way to define a number with a readable, describable name. So that's all constants are. Now there's also this idea of scope that we're going to talk about next. And scope and variables, scope and constants, they kind of are interrelated a little bit. And let's talk about what scope is. Scope is the availability of a variable name or a constant name within your program. Where is it actually available? So for instance, I created an integer variable here, and I created constants here within these open and close curly brackets. So these variables are defined within the scope of the main function. They are within those open and closed braces. I can do this. I don't know why you'd want to do this, but I can do this. I can create an open and closed brace within the main open and closed brace. I can create an integer, but when I leave that open and closed brace, that my int2 is not available outside of that because that integer was defined, that variable is defined within that scope, and it cannot be accessed outside of that scope. However, anything defined in the superscope, as I like to call it, so the main scope is the superscope, and this is what I like to call a subscope. I have no idea if that's an interesting term, but I like using it when I teach. I can output variables or constants defined outside of the subscope. So the superscope, again, I don't know if that's a term. I don't think I've ever heard it used in industry, but I use it when I talk about this when I teach. So this is the superscope of the main function. This is the subscope within the main function. Anything defined within the subscope cannot be accessed from the superscope, but anything in the superscope, defined in the superscope, can be accessed in the subscope. Now, I said earlier, why would you ever want to create something like this? Well, you really wouldn't. We're going to jump ahead a little bit, and we're going to talk about functions a little bit. A function, the main function right here, it is a function because it has a return type, it has a name, and it has a set of parentheses that indicate what kind of data is going to be sent to that function. Well, I can create another function, and that's going to return an integer. We're going to call it add2. It's going to get 2 integers, and it's going to simply return, or actually it's going to define a variable. It's going to do a little equation. I know this isn't the most efficient or smallest code. I don't care. I'm teaching, I'm not writing high performance code. So this is another function that I've just created. Now there's going to be a whole set of videos on functions, but this is a good way to show you a real world example of scope. So this is a function called add2. It returns an integer. It takes 2 arguments, integer 1 and integer 2. I send those when I call the add2 function. I send that function those 2 variables. Within add2, it creates its own variable called return value. It adds int1 and int2. There's going to be a simple arithmetic video in C++ coming very soon. In fact, it might come right after this one. I assign that sum to return value, and then I return value back to whoever called me. Now, let's go ahead and call that function. So I'm going to say integer, I'm just going to say my int equals add2, and I'm going to send it 2 values, 10 and 20. and then I count my int. So let's save and build that. Let's make sure it built okay. And I'm just going to run it. Now this is the first time I ran it, so it's going to ask me that. And there's my 30. So what actually happened here? I said call add2. The program jumped up to here. Int 1 has a value of 10. Int 2 has a value of 20. It created its own local variable within its own scope. It said that variable is equal to the value of int 1 and int 2, which was 10 and 20. I return value. The return value is put into my int, and then I print my int, and it printed a 30. So that's an introduction to a function. Now, why am I showing you that? Because if I try to access return value from within main, it doesn't know anything about it. It says return value was not declared in this scope because there's no indication of it within main. It's not even declared inside of the subscope of main. That subscope. Where was it defined? It was defined up here in this scope, which belongs to add2. Now, it also means that add2 cannot access anything inside of main because add2 doesn't have an int or an integer called myInt defined within its scope. It's defined within the scope of main. And the same thing goes with constants. Like if I want to print the constant my age, that won't work either because that constant was defined within that scope. So scope is a variable, or where the variable is defined within the open and closed braces, in this case a function, in this case the main function, or in even a subscope of a function is where it's defined. So that's what you remember about scope. Now there's one last thing I want to talk about in this video, and that's global constants and global variables. Now because these constants and constants and variables were defined inside of a function inside that scope, they're only available within that scope. You might be very, very tempted to do this. Well, that's making life really complicated, so I'm just going to stick it out here into the global scope area. These two constants, my age and my height, are now global. And if you notice, before I move those out there, add2 got an error when I was probably trying to print my age. Now when I print it, no problem. Because my age and my height are global. Because they're outside of any scope. Oh my God, my life is going to be so much easier if I do it that way. Wrong. Most companies, most development houses hate global variables. Now a global constant is okay. I don't have a problem with a global constant because all it is a find replace. Everywhere where it sees my age, it replaces it with the number 39. Everywhere where it sees my height, it replaces it with the number 72. So most companies don't care. I mean, C limits. I think we did that earlier. Did I delete that? I must have deleted that. Oh no, int max. Int max is a global constant because it's part of the C limits include file. So not a problem. Constants really aren't a problem. However, when you do start doing stuff like this, moving actual variables up here to global, that's when people are going to start getting really upset. Because you're not going to know where that variable was changed when a problem occurs. And a problem will occur in your code. If you think you're going to write perfect code, you're in your own little coding bubble and you don't know what reality is. You are going to have problems in your code. And over years and years of coding and development and research on languages, it has been found that global variables can be a huge problem when trying to debug a program. It might make your coding easier. I mean, if I put all these variables outside as a global variable, all of a sudden all of my program compiles. And every function can use every one of these global variables. But what if I have 50 or 100 functions that are messing around with a global variable? How do I know which one screwed up that global variable if there's a defect? So it's really a bad idea to do that. Constants, it's okay. But when it comes to actual variables, you really should stay away from that because it just is not accepted. So that is our discussion of constants, scope, and global variables. Do not use global variables. Global constants are okay. As a summary, scope is where a variable is defined. It's only available within that scope and within any subscopes within that. And constants are values that cannot, or variables that can, they're not variable, so I don't even like calling them variables. They're constants, they're labels of a value that is replaced wherever it's seen in your code by the preprocessor and compiler. I don't even believe they take up memory. I've tried to find evidence that when you create a constant, it actually takes up memory. I can't find any evidence of that. So files that have, or C++ programs that have 500 constants are exactly the same size as the same program with no constants. So I haven't been able to find any evidence that it actually takes up memory, where variables do. Okay, that's our discussion. Hope to see you at the next video.